Querying vector database. Description. The process of searching for the nearest neighbors or similar vectors to a given query vector in a vector database. Steps. Step. Initialize vector database connection. Description. Set up the connection to the vector database. Implementation. FICE. Import FICE. D128 dimension of vectors. Index FICE. Read index vector index. FICE. Annoy. From Annoy import Annoy index. D128 dimension of vectors. Index Annoy indexed. Angular. Index. Load vector index.an. Milvus. From Pimilvus import connections. Collection. Connections. Connect default. Host localhost. Port 19530. Collection example collection. Step. Prepare query vector. Description. Prepare the query vector for which similar vectors need to be found. Implementation. Import NumPy as NP. Query vector NP. Random. Random1. D. As type float 32. Step. Execute search. Description. Perform the search for the nearest neighbors of the query vector. Implementation. FICE. K5 number of nearest neighbors to search for. D. I index. Search query vector. K. D contains the distances. I contains the indices of nearest neighbors. Annoy. K5 number of nearest neighbors to search for. Nearest neighbors index. Get NNS by vector query vector. Tolist 0. K. Include distances true. Nearest neighbors 0 contains the indices. Nearest neighbors 1 contains the distances. Milvus. K5 number of nearest neighbors to search for. Search params metric type L2. Results collection. Search query vector. Tolist. Vector. Param search params. Limit. Results contain the search results with distances and IDs. Step. Process and return results. Description. Process the search results and return the nearest neighbors. Implementation. FICE. Nearest neighbors id int 0i. Distance float d0i for I in Rangek. Return nearest neighbors. Annoy. Nearest neighbors id int nearest neighbors 0i. Distance float nearest neighbors 1i for I in Rangek. Return nearest neighbors. Milvus. Nearest neighbors id result.id. Distance result. Distance for result in results 0. Return nearest neighbors. Example usage. FICE. Import FICE. Import NumPy as NP. D128 dimension of vectors. Index FICE. Read index vector index. FICE. Query vector NP. Random. Random1. D. As type float 32. K5. D. I index. Search query vector. K. Nearest neighbors id int 0i. Distance float d0i for I in Rangek. Print nearest neighbors. Annoy. From Annoy import Annoy index. Import NumPy as NP. D128 dimension of vectors. Index Annoy indexed. Angular. Index. Load vector index.an. Query vector NP. Random. Random D. Tolist. K5 number of nearest neighbors to search for. Nearest neighbors index. Get NNS by vector query vector. K. Include distances true. Nearest neighbors id int nearest neighbors 0i. Distance float nearest neighbors 1i for I in Rangek. Print nearest neighbors. Milvus. From Pimilvus import connections. Collection. Import NumPy as NP. Connections. Connect default. Host localhost. Port 19530. Collection example collection. Query vector NP. Random. Random1. 128. Tolist. K5 number of nearest neighbors to search for. Search params metric type L2. Results collection. Search query vector. Vector. Param search params. Limit. Nearest neighbors id result.id. Distance result. Distance for result in results 0. Print nearest neighbors. Considerations. Data preprocessing. Description. Ensure vectors are normalized and preprocessed consistently. Search performance. Description. Tune search parameters like the number of trees in ANOI or the search method in FAISS for optimal performance. Index updates. Description. Consider how to handle updates to the index, such as adding new vectors or removing outdated ones. Distance metrics. Description. Choose appropriate distance metrics, e.g. L2. Cosine similarity based on the use case. Scalability. Description. Ensure the vector database can scale to handle large datasets and high query volumes.